Hello there, and welcome. Tonight I want to take you somewhere extraordinary, somewhere that exists right here, right now, all around us, yet remains invisible to our everyday perception. As you settle in, perhaps adjusting your pillow, finding that perfect comfortable position, I want you to consider something that might seem impossible at first, something that challenges everything we think we know about our place in the universe. We're going to explore a question that has been whispered in the halls of observatories, pondered by philosophers gazing at the night sky, and perhaps, just perhaps, already answered by civilizations we cannot yet perceive. It's a question that might initially spark skepticism, that might make you wonder if such thoughts belong more to science fiction than science fact. But what if I told you that some of the most brilliant minds in astrophysics and cosmology have been quietly considering this very possibility? What if Earth, our beautiful blue marble floating in the cosmic dark, isn't as isolated as we've always believed? What if we're actually residing alongside something far more ancient and travelled than we've ever imagined? What if, just maybe, we're living in a quiet galactic highway? Now, before you dismiss this as mere fantasy, let me share something with you. Every night as you drift off to sleep, cosmic rays from distant stars pass through your body. Neutrinos, those ghostly particles born in the hearts of dying suns, stream through you by the trillions without you ever noticing. Radio waves from pulsars that died before Earth was born wash over your home in waves of ancient information. We are constantly bathed in the invisible traffic of the cosmos, and yet we go about our daily lives completely unaware of this cosmic commerce happening all around us, through us, within us. Consider this for a moment, and I know this might sound unusual, but perhaps you're watching this from somewhere special right now. Maybe you're in New York where it's past midnight, the city that never sleeps finally quieting down, or perhaps you're in London where the early morning hours are creeping in, or somewhere in Tokyo where the afternoon sun is beginning its descent. Wherever you are, whatever time zone cradles you at this moment, you're part of this cosmic story we're about to explore together. And if you find this journey intriguing, if these thoughts spark something within you, I'd love to know where you're listening from, what time decorates your corner of our spinning world. Feel free to share your thoughts in the comments below, and if this cosmic contemplation resonates with you, perhaps consider subscribing to join us on future journeys through the mysteries of space. Sometimes the most profound connections we make are with strangers across the globe, united in our wonder at the cosmos above. The idea of galactic highways isn't as far-fetched as it might initially seem. When we look at our own planet, we see that life has always followed pathways. Birds migrate along invisible magnetic highways in the sky, following routes passed down through countless generations. Ocean currents create underwater highways that marine life has travelled for millions of years. Even our earliest human ancestors followed specific routes out of Africa, pathways determined by climate, geography, and the availability of resources. Nature, it seems, abhors randomness when it comes to travel. There are always preferred routes, optimal pathways, corridors of least resistance. So why should the galaxy be any different? Why should we assume that interstellar travel, if it exists, would be random and chaotic rather than following predictable, efficient routes? Perhaps there are cosmic currents we haven't yet learned to see, gravitational streams that make certain paths through space more favourable than others. Perhaps advanced civilizations have been using these routes for millions or even billions of years, passing by our solar system like ships in the night, silent and unnoticed. Think about how recently we've become aware of our cosmic surroundings. If you compressed the entire history of Earth into a single year, with the planet forming on January 1st, humans wouldn't appear until December 31st at about 11:30 p.m. Our entire recorded history would occupy only the last few seconds before midnight, and our ability to detect anything beyond our own atmosphere, that would be less than the blink of an eye. We've been listening to the cosmos with radio telescopes for less than a century, searching for signs of intelligence for even less time than that. In cosmic terms, we've barely just opened our eyes. And what eyes they are. We've built magnificent instruments to peer into the darkness, telescopes that can see billions of light years into space, detectors that can sense the faintest whispers of radiation from the edge of the observable universe. Yet for all our technological prowess, we might be looking for the wrong things, listening on the wrong frequencies, searching in the wrong places. It's entirely possible that evidence of galactic highways exists all around us, but we simply don't know how to recognize it yet. Imagine, if you will, an ant colony built beside a major human highway. The ants go about their daily business, gathering food, building their tunnels, raising their young, completely unaware of the cars rushing by just meters away. To them, the vibrations might be earthquakes, the exhaust fumes might be mysterious weather patterns, the occasional dropped piece of food might be manna from heaven. They have no concept of vehicles, of transportation networks, of the vast civilization that built and uses that highway. They live their entire lives in the shadow of something beyond their comprehension. Could we be those ants? Could Earth be positioned near something so advanced, so beyond our current understanding, that we simply cannot recognize it for what it is? The possibility is both humbling and extraordinary. It suggests that we might not be alone, that we might be part of something far grander than we've ever imagined, even if we're not yet aware of it. The night sky, which seems so quiet and still to our eyes, might actually be bustling with activity we cannot perceive, just as a highway seems silent to a deaf person watching from a distance. The cosmos might only appear empty because we haven't yet developed the senses to detect its traffic. We judge the universe by our own limitations, assuming that because we cannot see or hear something, it must not exist. But the history of science is littered with discoveries of things that were always there, waiting patiently for us to develop the tools and understanding to perceive them. Radio waves existed long before Marconi. X-rays were streaming through space long before Röntgen. Gravity waves were rippling through the fabric of space-time long before LIGO detected them. Each of these discoveries revealed a hidden layer of reality that was always present, always active, just beyond our perception. What else might be out there, right now, passing through our solar system, undetected and unacknowledged? The concept of galactic highways also raises profound questions about the nature of intelligence and civilization. We tend to imagine alien civilizations as being somewhat like us, perhaps more advanced, but fundamentally similar in their needs and desires. We picture them in spacecraft not too different from our own concepts, using technologies that are extensions of what we know. But what if intelligence can evolve in ways we cannot fathom? What if consciousness can exist in forms we wouldn't recognize as life? What if the highways themselves are somehow alive, networks of intelligence that span the galaxy like neural pathways in a cosmic brain? These aren't just the idle speculations of science fiction writers. Serious scientists have proposed that advanced civilizations might upload their consciousness into pure energy. becoming beings of light that travel along laser beams between stars. Others have suggested that dark matter, that mysterious substance that makes up most of the matter in the universe, might be the infrastructure of civilizations so advanced that their technology is indistinguishable from the fundamental forces of nature. Still, others propose that advanced intelligences might exist in higher dimensions, passing through our three-dimensional space like shadows on a wall. As you lie there, perhaps feeling your consciousness beginning to soften around the edges, consider that you might be surrounded by layers of reality you cannot perceive, not in a frightening way, but in a way that fills the universe with infinite possibility. Every atom in your body was forged in the heart of a dying star. You're literally made of cosmic material assembled from elements that have travelled across the galaxy to be here, now, in this moment. You're already part of the cosmic highway system, whether you realise it or not. The calcium in your bones might have been part of another planet orbiting another star. The iron in your blood might have witnessed the birth of galaxies. The water in your cells might have been ice on comets that sailed between solar systems for millions of years. You are a collection of cosmic travellers, temporarily assembled into the pattern that is you, but eternally connected to the vast network of matter and energy that flows through the universe. This perspective transforms the question from, are we near a galactic highway, to, how could we not be? We are made of the universe, by the universe, in the universe. We are not separate from the cosmic flow, we are expressions of it. Every breath you take exchanges atoms with the atmosphere, which exchanges atoms with space, which exchanges particles with the entire cosmos. You are not just on a galactic highway, you are part of it. But let's return to the more conventional idea of highways as routes of travel, pathways between destinations. If advanced civilizations do traverse the galaxy, what might their highways look like? We can only speculate, but we can ground our speculation in what we know about physics and the structure of the universe. Perhaps they follow gravitational corridors, those paths through space where the combined pull of stars and galaxies creates channels of least resistance. Perhaps they utilize wormholes, those theoretical shortcuts through space-time that could connect distant regions of the universe. Perhaps they ride on beams of light itself, their consciousness encoded in photons that stream between stars at the ultimate speed limit of the universe. Or perhaps, and this is where it gets really interesting, perhaps they don't travel through space at all, in any way we would recognize. Perhaps they've learned to step outside of space-time entirely, moving through dimensions we cannot perceive, appearing as disappearing like quantum particles that pop into and out of existence. To them, our concept of distance might be as quaint as a flat Earth map is to us. They might be able to be anywhere and everywhere simultaneously, making the very concept of highways obsolete. Yet even if such advanced methods of travel exist, there might still be reasons for highways, for preferred routes through the galaxy. Economics, even cosmic economics, might favour certain paths. Safety might dictate avoiding certain regions of space. Cultural or biological preferences might make some routes more appealing than others. The galaxy is not uniform, it has structure, patterns, areas of density and emptiness. Any intelligence navigating it would likely take these factors into account. Our solar system sits in what we call the local bubble, a region of relatively empty space carved out by ancient supernovae. We're in the Orion arm of the Milky Way, a minor spiral arm between the major Perseus and Sagittarius arms. We're about 26,000 light-years from the galactic center in what might be considered the suburbs of our galaxy. Is this a good location for a highway? A bad one? Or are we perhaps in the cosmic equivalent of a rest stop, a quiet place off the main routes where travelers might pause but not linger? The more we learn about our cosmic neighborhood, the more we realize how dynamic it is. Our solar system is moving through space at tremendous speed, orbiting the galactic center once every 225 million years. We're currently passing through the local interstellar cloud, and in about 10,000 years we'll emerge into a different region of space. Our night sky changes over these vast timescales. Stars that are neighbors now will be distant strangers in 1,000,000 years. New stars will become our companions. If there are highways, our relationship to them must be constantly changing. This cosmic dance raises fascinating possibilities. Perhaps Earth passes through high-traffic areas periodically, like a planet with seasons of isolation and seasons of connection. Perhaps there have been times in our past when the evidence of galactic highways was more obvious, and times when it was hidden. Perhaps we're approaching or leaving such a period right now. The dinosaurs saw different stars than we do. Our descendants will see different stars still. Each era of Earth's history has its own unique cosmic context. Consider too that what we perceive as empty space might be anything but. We've discovered that the vacuum of space seethes with virtual particles popping into and out of existence. Quantum fields permeate every cubic centimeter of the universe. Dark energy pushes space apart while dark matter holds galaxies together. What we once thought was nothing turns out to be a complex dynamic medium full of activity and potential. Perhaps galactic highways exist in this hidden complexity, utilizing aspects of space we're only beginning to discover. The search for extraterrestrial intelligence has always assumed we would recognize it when we found it. But what if intelligence has evolved to be indistinguishable from natural phenomena? What if the patterns we see in pulsars, the distributions of galaxies, the mysterious fast radio bursts we detect are actually the signatures of intelligence so advanced that we mistake it for nature? We might be like those ants beside the highway, interpreting the rumble of trucks as thunder, never realizing the artificial origin of what we observe. This isn't to say that every mysterious phenomenon in space is evidence of alien intelligence. That way lies paranoia and pseudoscience. But it does suggest that we should remain open to possibilities, that we should question our assumptions about what intelligence looks like and how it might manifest on cosmic scales. The universe is far stranger than we once imagined, and it keeps getting stranger the more we learn. Why should intelligence be any less surprising? As we continue our journey tonight, we'll explore these ideas in greater depth. We'll look at the actual structure of our galaxy and how it might influence travel routes. We'll examine the mysterious phenomena that could be evidence of cosmic engineering. We'll consider the vast scales of time over which galactic civilizations might operate, and we'll ponder what it all means for humanity, for our future, for our place in the cosmic order. But for now, as you settle deeper into comfort, let this thought wash over you like a gentle wave. You are part of something vast and mysterious. Whether or not galactic highways exist in the way we might imagine them, you're connected to every star you see and every star you don't. The atoms in your body have travelled impossible distances to be here. You are a way for the universe to know itself, a brief flowering of consciousness in an ocean of matter and energy that stretches to infinity. The question isn't really whether we're near a galactic highway. The question is whether we're ready to recognize it if we are. Are we prepared for the possibility that we're not alone? Are we mature enough as a species to take our place in a galactic community if one exists? Or are we still too young, too volatile, too dangerous to ourselves and others? Perhaps the highways are quiet around Earth not because they don't exist, but because we're not yet ready to join the traffic. These are profound questions without easy answers. They require us to think beyond our daily concerns, beyond our human timescales, beyond our terrestrial perspective. They ask us to imagine ourselves as part of something larger, something that transcends our individual lives and even our species. They invite us to wonder, to dream, to reach beyond what we know toward what might be possible. And perhaps that's the real value of contemplating galactic highways. Whether or not they exist in any physical sense, thinking about them expands our consciousness, stretches our imagination, and connects us to the cosmos in a deeply personal way. Every time you look up at the night sky and wonder if someone is travelling between these stars, you're participating in a tradition as old as humanity itself. You're joining countless generations who have gazed upward and asked, "What's out there? Are we alone? What does it all mean?" The answers, if they come, might not arrive in our lifetime. They might not arrive in the lifetime of our species. But the questions themselves are valuable. They make us more than we would be without them. They turn us from creatures merely existing on a planet into conscious beings contemplating our place in the universe. They transform us from passengers into participants in the cosmic story. So as you drift towards sleep tonight, carried on the gentle current of these thoughts, remember that you're not just lying in bed on a small planet orbiting an ordinary star. You're a conscious point in a vast web of matter and energy, a unique perspective in an infinite cosmos, a traveller on a journey that began with a big bang and continues toward an unknown destination. Whether galactic highways exist or not, you're already on the greatest journey possible, the journey of existence itself. And in that journey, every night's sleep is a small death and rebirth, a rehearsal for the greater transformations that await all matter and energy in the universe. Your consciousness fades and returns like stars being born and dying, like civilizations rising and falling, like waves on a cosmic ocean that has no shore. You're the universe experiencing itself, dreaming itself, questioning itself. And in your questions, in your wonder, in your willingness to contemplate the impossible, you honour the mystery that surrounds us all. The scale of space is something our minds were never evolved to comprehend. We developed our intuition in a world where the horizon was the limit of our vision, where a day's walk was a significant journey, where the fastest thing we knew was a running predator or prey. Our brains are calibrated for distances measured in meters and kilometers, not light years and parsecs. Yet here we are, trying to understand a universe so vast that even light, the fastest thing possible, takes billions of years to cross it. Tonight, let's gently stretch our imagination to encompass these impossible distances and consider how beings might navigate such incomprehensible vastness. If you were to drive a car at highway speed toward the nearest star, Proxima Centauri, it would take you over 40 million years to arrive. That's longer than the time since our earliest ancestors diverged from other apes. If you could travel at the speed of our fastest spacecraft, it would still take you over 70,000 years. Even at the speed of light, the absolute limit according to our current understanding of physics, it would take more than 4 years. And that's just to our nearest stellar neighbour, a cosmic stone's throw away in the grand scheme of things. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. If you could visit one star every second, it would take you over 10,000 years to see them all. But the stars aren't conveniently arranged for touring. They're spread across a disk roughly 100,000 light-years in diameter. To cross our galaxy at light speed would take longer than our species has existed. And our galaxy is just one of trillions in the observable universe, each one an island of stars in an ocean of darkness that defies comprehension. Yet perhaps we're thinking about this all wrong. We assume that distance is an insurmountable obstacle because it is for us. We project our limitations onto the cosmos and conclude that interstellar travel must be impossibly difficult, maybe even impossible, period. But what if distance isn't the barrier we think it is? What if there are ways to navigate the galaxy that don't involve crossing every meter of space between here and there? What if the architecture of the cosmos itself provides shortcuts, corridors, pathways that we haven't yet learned to see? Consider how we've already discovered that space isn't uniform. It has structure, patterns, currents, and flows. Galaxies aren't randomly distributed. They form vast cosmic webs, with filaments of matter stretching between nodes of galactic clusters and great voids of nearly empty space between them. Dark matter, invisible to our telescopes but detectable through its gravitational effects, forms an even larger structure, a skeleton upon which visible matter hangs like decoration. If you could see dark matter, the universe would look completely different, perhaps revealing highways we cannot currently perceive. Within our own galaxy, we've discovered streams of stars, rivers of suns flowing through space together, born from the same cosmic nurseries or torn from smaller galaxies that our Milky Way consumed. We found bubbles in the interstellar medium, regions cleared out by ancient supernovae, where the density of matter is far lower than average. We've identified spiral density waves, regions where stars cluster more tightly as they orbit the galactic center. The galaxy isn't just a random collection of stars. It has geography, topology, structure that might define natural pathways for travel. And then there's gravity, the architect of the cosmos, the force that shapes everything from planets to galactic superclusters. Gravity creates wells and hills in space-time, warping the fabric of reality itself. Massive objects like stars and black holes bend space around them, creating curves that other objects follow. What we perceive as the force of gravity is really the curvature of space-time, and that curvature creates natural paths, geodesics, along which objects travel with the least expenditure of energy. Perhaps advanced civilizations have learned to read these gravitational patterns like we read maps. Perhaps they've discovered how to surf gravitational waves, riding the ripples in space-time caused by colliding black holes or neutron stars. Perhaps they use the gravitational fields of stars and planets like slingshots, accelerating without fuel, dancing through the galaxy on trajectories we would consider impossible. The galaxy might be crisscrossed with gravitational highways invisible to our eyes, but as real as the trade winds that carried sailing ships across Earth's oceans. Or consider an even more exotic possibility: wormholes. These theoretical shortcuts through space-time could connect distant regions of the universe, allowing travel between them without crossing the intervening space. While we've never observed a wormhole, they're permitted by Einstein's equations, and some physicists believe they might naturally occur, especially in the extreme conditions near black holes or in the quantum foam at the smaller scales of reality. If wormholes exist and can be stabilized, they would be the ultimate cosmic highways, allowing instant travel across impossible distances. But even without such exotic physics, the sheer age of the galaxy provides opportunities for travel we might not have considered. Our galaxy is over 13 billion years old. That's enough time for patient civilizations to spread across it even at relatively slow speeds. If a civilization could travel at just 1% of light speed, they could colonize the entire galaxy in a few million years, a blink of an eye in cosmic terms. They wouldn't need faster-than-light travel or wormholes or any technology beyond what we can currently imagine. They would just need patience and persistence on scales that dwarf human experience. Imagine civilizations that think in geological time, for whom a million years is like a decade to us. To them, the galaxy might not seem impossibly vast, but merely large, challenging but navigable. They might send out waves of colonization that take millennia to reach their destinations, establishing outposts that grow into civilizations of their own, which send out their own waves in turn. The galaxy might be filled with the descendants of ancient expansions, layers upon layers of colonization spreading like ripples in a pond. These civilizations might follow specific routes determined by the distribution of useful resources, just as human trade routes on Earth followed rivers, coastlines, and mountain passes. Galactic highways might follow chains of resource-rich solar systems. Certain types of stars might be preferred for their stability or energy output. Planets with specific characteristics might serve as way stations. Asteroid belts might be mining sites. The galaxy might have an economy we cannot perceive, with trade routes carrying materials and information between distant outposts. The concept of the galactic habitable zone adds another layer to this cosmic geography. Not all parts of the galaxy are equally suitable for life as we know it. Too close to the galactic centre, and radiation from the supermassive black hole and the density of stars make conditions hostile. Too far out in the galactic halo, and there might not be enough heavy elements to form rocky planets. There's a sweet spot, a ring around the galaxy where conditions are just right for life to emerge and thrive. Perhaps galactic highways preferentially pass through this zone, connecting the worlds most likely to harbour life. Our solar system's position in this galactic habitable zone might not be coincidental. Perhaps we're here because this is where life can exist long enough to evolve intelligence. But it also might mean we're in a cosmic thoroughfare, a region where intelligent species are more likely to emerge and where travellers might expect to find interesting destinations. We might be living in the galactic equivalent of a populated coastline, where civilizations naturally cluster and interact. The movement of stars through the galaxy adds a dynamic element to this picture. Stars don't stay in fixed positions. They orbit the galactic centre at different speeds, passing by each other in a slow, cosmic dance. Our Sun completes an orbit every 225 million years, but other stars have different periods. This means the stellar neighbourhood is constantly changing. Stars that are far apart now might have been neighbours in the past or might become neighbours in the future. Galactic highways might need to be dynamic, adjusting to the changing positions of stars like shipping routes that change with the seasons. This stellar motion might create periodic opportunities for travel, times when stars align in ways that make certain journeys easier. Perhaps there are optimal times for crossing between spiral arms, or moments when stellar clusters pass close enough to allow easy transit between them. Advanced civilizations might plan their expansions around these cosmic alignments, waiting centuries or millennia for the perfect moment to launch their journeys. The galaxy might pulse with waves of migration tied to its rotation and evolution. We should also consider that our three-dimensional perspective might be limiting our understanding. While we perceive space as having 3 dimensions, theories like string theory suggest there might be additional dimensions we cannot directly observe. These extra dimensions might be compact, curled up at scales too small for us to detect, or they might be large but inaccessible to us because we're confined to our 3-dimensional brain, like shadows on a wall. If advanced civilizations have learned to access these extra dimensions, they might be able to take shortcuts through higher dimensional space, appearing to travel faster than light from our limited perspective. The nature of time itself might be different for galactic travelers. Einstein showed us that time is relative, that it flows at different rates depending on velocity and gravity. A civilization traveling at high speeds would experience time dilation, with time passing more slowly for them than for stationary observers. A journey that takes thousands of years from Earth's perspective might only take years or decades for the travelers. This time dilation might make galactic travel more practical than we imagine, allowing civilizations to spread across the galaxy within the lifespans of individual beings. Or perhaps advanced civilizations have transcended biological limitations entirely. If consciousness can be uploaded into artificial substrates, if intelligence can exist in pure information, then the constraints of biological time might not apply. Digital beings could slow down their subjective time, experiencing centuries as moments, or speed it up, living entire lifetimes in seconds. For them, the vast distances of space might be irrelevant. They could transmit themselves as information at the speed of light, reconstructing themselves at their destination. The galaxy might be full of intelligence flowing along beams of light, a kind of cosmic internet we cannot yet detect. The distribution of dark matter might play a crucial role in galactic navigation. Dark matter outweighs visible matter by a factor of 5 to 1, and its gravitational effects shape the structure of galaxies. There might be dark matter streams and currents that provide natural pathways through space. Advanced civilizations might have learned to detect and utilize dark matter in ways we cannot imagine, perhaps even using it as fuel or building material. The dark matter web might be the true highway system of the galaxy, with visible matter just the landmarks along the way. As we contemplate these possibilities, it's worth remembering that our understanding of physics is incomplete. We've only recently discovered dark energy, the mysterious force that's accelerating the expansion of the universe. We don't understand what happens inside black holes or at the quantum scale. We haven't unified quantum mechanics and general relativity. There might be entire categories of phenomena we haven't discovered yet, forces and particles and fields that advanced civilizations routinely exploit. The galaxy might be rich with possibilities we cannot currently imagine. The concept of Dyson spheres and other megastructures suggests another aspect of galactic architecture. Advanced civilizations might reshape entire solar systems, surrounding stars with shells or swarms of satellites to capture their energy. These megastructures would be visible across vast distances, serving as beacons or landmarks in the galaxy. They might form nodes in a galactic network, points where highways converge and civilizations interact. The galaxy might be dotted with these artificial constructs, invisible to our current telescopes but obvious to those who know how to look. Communication across galactic distances presents its own challenges and opportunities. Even at light speed, messages take years or decades to cross between stars. But perhaps advanced civilizations have discovered faster-than-light communication using quantum entanglement or other phenomena we don't yet understand. Or perhaps they've accepted the limitations of light speed and built their societies around long communication delays, with each stellar system operating autonomously, but connected through a slow network of information exchange. The galaxy might be united not by instant communication but by patient, persistent dialogue across the centuries. The search for resources might drive galactic traffic patterns. While hydrogen, the most abundant element, is everywhere, heavier elements are rarer and unevenly distributed. Certain types of stars produce specific elements when they die. Neutron star collisions create gold and other heavy metals. Supernovae scatter these elements into space, where they can be incorporated into new stars and planets. Civilizations might track these cosmic events and harvest their products, following routes determined by the galaxy's chemical evolution. As our instruments become more sensitive, we're discovering that the galaxy is full of rogue planets, worlds ejected from their solar systems and drifting through interstellar space. There might be billions of these dark wanderers, invisible to our telescopes but potentially useful to advanced civilizations. They could serve as stepping stones between stars, temporary bases for travelers, or sources of raw materials. The spaces between stars might be far less empty than we imagine, filled with resources and opportunities for those who know how to find them. The galactic center, with its supermassive black hole and dense stellar population, might be a hub of activity we cannot perceive. The extreme conditions there might be exactly what advanced civilizations need for their technologies. Black holes might be power sources, computational devices, or gateways to other regions of space. The intense radiation might be harnessed rather than avoided. What seems hostile to us might be ideal for beings with different needs and capabilities. The galactic center might be a cosmic metropolis, bustling with activity we mistake for natural phenomena. The universe should be noisy. That's what the math tells us. With hundreds of billions of stars in our galaxy alone, and billions of years for life to evolve and spread, we should be surrounded by the chatter of countless civilizations. Radio signals should be crisscrossing space like invisible lightning. Laser beams should be painting messages across the void. The evidence of intelligence should be everywhere, unmistakable, undeniable. Yet when we listen to the cosmos, we hear only silence. This is the great paradox that haunts our nights and challenges our assumptions about our place in the universe. Enrico Fermi, the brilliant physicist who helped usher in the atomic age, posed the question simply over lunch one day in 1950. Where is everybody? If the universe is as old and vast as we know it to be, if life emerges naturally from chemistry, if intelligence is a probable outcome of evolution, then why haven't we encountered anyone else? Why does the galaxy seem empty of intelligence except for us? This question, now known as the Fermi paradox, has no easy answer, but perhaps that's because we're not listening carefully enough to the silence. Silence, after all, is never truly silent. In a quiet room, you can hear your heartbeat, your breathing, the subtle sounds of your body maintaining itself. In a forest at night, what seems like silence is actually a symphony of small sounds. Insects chirping, leaves rustling, air moving through branches. Even in the vacuum of space there are whispers. The cosmic microwave background radiation, the faint echo of the Big Bang, carries information about the universe's birth. Perhaps the great silence of the cosmos is similarly full of whispers we haven't learned to interpret. Consider how recently we've gained the ability to listen to space at all. Radio astronomy is less than a century old. We've been seriously searching for extraterrestrial intelligence for only about 60 years. That's nothing in cosmic terms, less than a heartbeat in the life of the galaxy. We're like someone who just walked into a vast library and, having glanced at a few book spines, declares that the library contains no books in their language. We've barely begun to search, and already we're wondering why we haven't found anything. But perhaps we have found things, and we just don't recognize them for what they are. The history of astronomy is full of discoveries that were initially mysterious, that took years or decades to understand. Pulsars, when first detected, were so regular that they were initially called LGM1 for little green men, because their precise pulses seemed artificial. Fast radio bursts, powerful millisecond flashes of radio waves from distant galaxies, remain largely unexplained. Could some of these mysterious phenomena be the signatures of intelligence? Not necessarily direct communication attempts, but the waste heat of vast technologies, the exhaust of cosmic engines, the side effects of projects beyond our imagination, the assumption that alien civilizations would use radio waves to communicate might be hopelessly anthropocentric. We've used radio for communication for barely more than a century, and we're already moving toward more efficient technologies. Our own radio emissions are decreasing as we switch to fiber optics and directed beams. An alien civilization observing Earth from a distance might have detected our radio bubble for only a brief window of time before we fell silent again. Perhaps all civilizations go through a brief radio phase before moving on to something better, something we haven't discovered yet. What if advanced civilizations communicate using neutrinos, those ghostly particles that pass through matter almost unimpeded? A neutrino beam could traverse the galaxy without being absorbed or scattered, delivering messages with perfect fidelity. Or perhaps they use gravitational waves, ripples in space-time itself, to send information. These waves pass through everything, unaffected by dust or gas or electromagnetic fields. We've only just learned to detect gravitational waves, and our instruments are still primitive. There might be a rich spectrum of gravitational communication happening all around us, as invisible to us as radio waves were to our ancestors. Or consider the possibility that communication might not be electromagnetic or gravitational at all. Perhaps advanced civilizations have discovered new physics, new forces or particles or fields that we haven't yet imagined. They might be communicating through dimensions we cannot perceive, or using quantum entanglement to send instantaneous messages across vast distances. The silence we perceive might be like a deaf person standing in a concert hall, unaware of the music filling the air. There's also the sobering possibility that civilizations might choose to be quiet. This is the dark forest hypothesis. The idea that the galaxy is full of civilizations hiding from each other, maintaining radio silence for fear of attracting hostile attention. In this scenario, broadcasting your presence to the cosmos is like shouting in a dark forest full of predators. The wise stay quiet, communicate only through directed, encrypted channels, and avoid any activity that might reveal their location. The silence isn't empty, it's purposeful, a galaxy holding its breath. But perhaps the silence isn't about fear, but about efficiency. Advanced civilizations might have learned that broadcasting omnidirectionally into space is wasteful. Instead, they might use highly directed communications, tight beams of information sent only where needed. The galaxy might be full of these narrow communication beams, crisscrossing space like laser pointers in the dark, never intersecting with Earth because we're not the intended recipient. We might be surrounded by conversations we're not part of, messages not meant for us. The zoo hypothesis presents another intriguing possibility. Perhaps Earth is intentionally isolated, a preserve where life can evolve naturally without interference. Advanced civilizations might have agreed to leave emerging worlds alone, to let them develop at their own pace. The silence might be enforced, a quarantine to protect us from influences we're not ready for. In this scenario, the galaxy might be teeming with communication, but it's deliberately routed around us, like highways bypassing a nature reserve. Timescales might play a crucial role in the apparent silence. Civilizations might rise and fall on timescales that rarely overlap. If a typical technological civilization lasts only a few thousand years, the chances of two civilizations being active at the same time and close enough to communicate might be vanishingly small. The galaxy might be full of ruins, the remnants of countless civilizations that blazed brightly and then faded. We might be surrounded by cosmic archaeology, the bones of dead civilizations, their signals long since faded to undetectable whispers. Or perhaps civilizations don't die but transform into something we wouldn't recognize as intelligence. They might upload themselves into virtual realities, living in simulated universes far richer than the physical one. They might merge with their technologies, becoming something post-human or post-biological. They might ascend to higher dimensions or different planes of existence. The silence might not indicate absence but transcendence, civilizations evolving beyond our ability to perceive or understand them. The Great Filter hypothesis suggests something more ominous. Perhaps there's some challenge, some barrier that prevents life from becoming spacefaring. This filter might be behind us, meaning we're incredibly rare, one of the few forms of life that have made it this far. Or it might be ahead of us, a challenge that destroys civilizations before they can spread to the stars. The silence might be a warning, the quiet after a storm that destroyed everyone who came before us, or the calm before a storm we have yet to face. But let's return to the possibility that the silence is full of whispers we haven't learned to hear. CT, the search for extraterrestrial intelligence, has traditionally looked for signals that stand out from the cosmic background, artificial patterns in the noise. But what if advanced civilizations have learned to hide their signals in the noise itself? What if they encode information in ways that look natural to us? The distribution of pulses, the patterns of fast radio bursts, the fluctuations in the cosmic microwave background. Any of these might contain messages we haven't recognized. Nature itself might be the medium of communication. Advanced civilizations might engineer stars to pulse in specific patterns, or arrange matter in ways that encode information. They might create artificial elements that serve as calling cards, or trigger supernovae in patterns that spell out messages across the galaxy. What we interpret as natural phenomena might be cosmic graffiti, billboards in space that we drive past without reading because we don't recognize them as signs. The search for intelligence might be hampered by our assumptions about what intelligence looks like. We imagine civilizations somewhat like ours, with similar needs and desires, using technologies we can extrapolate from our own. But intelligence might take forms we cannot imagine. It might exist in the magnetic fields of stars, in the quantum vacuum, in the patterns of cosmic rays. It might operate on scales so vast or so tiny that we overlook it entirely. We might be like bacteria trying to recognize human intelligence, lacking the conceptual framework to understand what we're looking for. Our position in the galaxy might also contribute to the silence. We're located in a relatively quiet suburb, far from the galactic center, where star density is highest. If civilizations cluster in certain regions, we might be in a cosmic backwater, far from the main channels of communication and travel. The silence might be geographical rather than temporal, a function of our location rather than our timing. We might need to wait for the galaxy's rotation to carry us into busier neighborhoods, a journey that will take millions of years. The anthropic principle offers another perspective on the silence. We observe a quiet universe, because that's the only kind of universe where we could exist to observe it. If the galaxy were bustling with advanced civilizations, Earth might have been colonized or destroyed long ago, preventing our evolution. The silence might be a prerequisite for our existence, a necessary condition for indigenous intelligence to arise. We see an empty galaxy because a full galaxy wouldn't have allowed us to develop. But perhaps the most intriguing possibility is that the silence is an illusion created by our limited perspective. We've been listening for such a short time, with such primitive instruments, searching such a tiny fraction of the possible frequencies and modulations. It's like trying to understand ocean currents by examining a single drop of water. The galaxy might be roaring with communication, throbbing with intelligence, alive with conversation, and we simply haven't developed the ears to hear it yet. Recent discoveries hint at the complexity we might be missing. We've found that some stars dim in ways that could indicate massive structures orbiting them. We've detected radio signals that repeat in patterns that seem almost artificial. We've observed cosmic rays with energies that challenge our understanding of physics. Each of these might be natural phenomena, or they might be whispers of intelligence, clues we haven't yet learned to interpret. This silence might also be teaching us patience. Perhaps contact between civilizations is rare, not because civilizations are rare, but because the conditions for successful contact are precise. Maybe civilizations need to reach a certain level of technological and social maturity before they're ready for contact. The silence might be a test, a filter that ensures only civilizations capable of long-term thinking and careful searching make contact. We might need to listen for centuries or a millennia before we hear anything, and that patience might be part of what qualifies us for membership in a galactic community. As we lie here in the darkness, contemplating the quiet cosmos, we might take comfort in the possibility that the silence is temporary. Perhaps tomorrow or next year or next century, we'll detect a signal that changes everything. Or perhaps we'll slowly realize that we've been detecting signals all along, that the universe has been trying to tell us something, and we're just now learning the language. The silence might be about to break, or it might be about to reveal itself as an illusion. The galaxy has structure, beautiful and complex patterns that emerge from the interplay of gravity, motion, and time. These patterns aren't random. They're the result of physical laws operating over billions of years, creating a kind of cosmic architecture that might serve as the foundation for galactic highways. Tonight, let's trace these patterns in starlight, following the natural pathways that wind through our galaxy, like ancient roads through a vast landscape. Spiral arms are perhaps the most obvious features of our galaxy's architecture. The Milky Way has several major spiral arms: Perseus, Sagittarius, Scutum Centaurus, and minor ones like the Orion arm where our solar system resides. These aren't solid structures, but density waves, regions where stars and gas clouds bunch up as they orbit the galactic center. Like traffic jams that maintain their position even as individual cars move through them, spiral arms are patterns that persist while stars flow in and out of them over millions of years. These spiral arms might serve as natural highways for interstellar travel. They're regions of higher star density, which means more potential destinations clustered together. They're also regions of active star formation, where new solar systems are constantly being born. A civilization expanding through the galaxy might follow these arms like ancient humans followed rivers, finding resources and opportunities concentrated along these cosmic thoroughfares. The gaps between spiral arms, relatively empty regions of space, might be like deserts or oceans, crossable, but requiring more preparation and resources. But the galaxy's structure goes deeper than what we can see with optical telescopes. Rivers of stars flow through space, stellar streams that tell stories of cosmic collisions and consumption. These streams are the remnants of smaller galaxies and star clusters that our Milky Way has torn apart and absorbed over billions of years. The stars in these streams move together, following similar orbits, creating corridors of related stars stretching across thousands of light years. The Sagittarius stream, for example, wraps around our entire galaxy, a river of stars torn from the Sagittarius dwarf galaxy that our Milky Way is currently devouring. The Helmi stream, the Orphan stream, the Monoceros ring, each is a pathway of stars with shared origins and similar motions. For a civilization capable of reading these patterns, stellar streams might be like trade winds or ocean currents, predictable routes that make certain journeys easier than others. Consider, too, the local bubble, our immediate cosmic neighborhood. We live inside a cavity in the interstellar medium, a region about 300 light-years across where the density of interstellar gas is much lower than average. This bubble was carved out by supernovae that exploded millions of years ago, clearing out the gas and dust that normally fills the spaces between stars. The result is a region of space that's easier to traverse, where spacecraft wouldn't need to push through as much interstellar material, where signals can travel with less interference. The local bubble is just one of many such structures in our galaxy. The galaxy is honeycombed with bubbles and superbubbles, cavities blown by stellar winds and supernovae, connected by tunnels and chimneys where hot gas flows. This network of low-density regions might form natural highways, paths of least resistance through the galaxy. Advanced civilizations might map these structures and plan their routes accordingly, like sailors using trade winds and currents to cross Earth's oceans. The galactic halo, that spherical region surrounding the disk of our galaxy, contains its own pathways. Ancient globular clusters orbit through the halo, each one a tightly packed sphere of hundreds of thousands of stars. These clusters are some of the oldest structures in the galaxy, formed when the universe was young. They follow long looping orbits that carry them through the galactic disk and back out into the halo. A civilization based in a globular cluster would have a mobile platform, a city of stars that travels through different regions of the galaxy over millions of years. Dark matter, invisible but undeniably present, creates its own geography. Dark matter doesn't interact with light, but its gravity shapes everything we can see. The Milky Way sits inside a vast dark matter halo that extends far beyond the visible stars. This halo isn't uniform, it has structure, clumps and streams and shells that we're only beginning to map. Dark matter streams flow through our galaxy, invisible rivers that might serve as guides or obstacles for interstellar travel. The Gaia mission has revolutionized our understanding of stellar motion in our galaxy. By precisely measuring the positions and velocities of over 1 billion stars, Gaia has revealed that our galaxy is far more dynamic than we imagined. Stars don't just orbit the galactic center in simple circles. They oscillate up and down through the galactic disk. They migrate inward and outward. They participate in complex resonances with the spiral arms and the galactic bar. The galaxy is alive with motion, and that motion creates patterns that repeat over millions of years. These patterns might be predictable enough to serve as the basis for navigation. Just as Pacific Islanders learned to navigate by reading wave patterns and ocean swells, galactic navigators might read the patterns of stellar motion to find their way through space. They might time their journeys to coincide with favorable alignments, waiting for stars to move into positions that make certain routes possible or efficient. The galaxy might have seasons, periods when certain pathways open and others close. Gravitational lensing provides another possible mechanism for galactic highways. Massive objects bend light and space around them, creating lenses that can magnify distant objects. A civilization that understood these lenses might use them as telescopes to observe distant regions of the galaxy, or even as communication relays, bouncing signals around the curved space-time near massive objects. The network of gravitational lenses throughout the galaxy might serve as both observatories and communication nodes, natural infrastructure that advanced civilizations could exploit. The interstellar medium itself, the gas and dust between stars, isn't uniformly distributed. It forms filaments and sheets, walls and voids, a cosmic web at all scales. The local fluff, the cloud of interstellar material our solar system is currently passing through, is just one small part of this structure. These clouds have edges and boundaries, regions where the density and composition change. Following the edges of these structures might be easier than pushing through their centers, creating preferred routes through space. Magnetic fields thread through the galaxy, invisible lines of force that guide charged particles and shape the flow of gas. These fields aren't uniform. They have structure, patterns that spiral with the galaxy's rotation, that bunch up in certain regions and spread out in others. Cosmic rays, charged particles accelerated to tremendous speeds, follow these magnetic field lines like trains on tracks. A civilization that could harness or navigate these fields might find highways already laid out for them, paths determined by the galaxy's magnetic architecture. The galactic center, home to a supermassive black hole and a dense cluster of stars, might be a hub in the galactic highway system. The extreme gravity and intense radiation might seem hostile to us, but they also represent tremendous energy that could be harnessed. The stars near the galactic center move at incredible speeds, whipping around the black hole in orbits that would seem impossible in quieter regions of space. These fast-moving stars might serve as slingshots, accelerating spacecraft to velocities that would be impossible to achieve elsewhere. Binary star systems, where two stars orbit each other, create their own unique opportunities for navigation. These systems have Lagrange points, positions where the gravitational forces of the two stars balance, creating stable locations where objects can remain with minimal energy expenditure. A network of stations at Lagrange points throughout the galaxy would provide rest stops and refueling stations for interstellar travelers. The periodic motion of binary stars might also create windows of opportunity, times when transfers between systems require less energy. Pulsars, rapidly rotating neutron stars that emit beams of radiation like cosmic lighthouses, might serve as navigational beacons. Each pulsar has a unique signature, a specific pattern of pulses that identifies it. A network of pulsars could serve as a galactic GPS system, allowing travelers to determine their position by triangulating from known pulsars. Some pulsars are so regular that they rival atomic clocks in precision, providing a stable time reference that could synchronize activities across the galaxy. The galaxy's chemical evolution creates gradients in the abundance of different elements. Heavier elements, forged in the hearts of dying stars, are more common in some regions than others. The galactic center is enriched with metals, while the outer regions are more pristine, dominated by hydrogen and helium. These chemical gradients might influence the routes civilizations take through the galaxy, seeking out regions rich in the elements they need for their technologies, or avoiding regions where crucial resources are scarce. Stellar nurseries, regions where new stars are born, might be destinations or waypoints on galactic highways. These regions are rich in raw materials, gas, dust, and young stars that haven't yet developed planetary systems. They're also laboratories where new worlds are constantly being created, offering opportunities for colonization or resource extraction. The Orion Nebula, visible to our naked eye as a fuzzy star in Orion's sword, is one such stellar nursery, a cosmic maternity ward where hundreds of stars are being born. The life cycle of stars creates a rhythm to galactic travel. Massive stars live fast and die young, exploding as supernovae after just a few million years. These explosions scatter heavy elements through space and can trigger the formation of new stars. Following the wave of star formation triggered by supernovae might be like following the seasons, moving through the galaxy in sync with its natural cycles of death and rebirth. Rogue planets, worlds ejected from their solar systems, drift through interstellar space in vast numbers. Recent estimates suggest there might be billions of these wandering worlds in our galaxy, dark and cold but potentially useful as stepping stones between stars. A civilization might establish bases on rogue planets, using them as slow-moving spacecraft that travel between stellar systems over millions of years. These nomad worlds might form an invisible network of waypoints throughout the galaxy. The concept of galactic habitable zones adds another dimension to potential highway routes. Not all regions of the galaxy are equally hospitable to life. The inner galaxy has too much radiation and too many stellar close encounters. The outer galaxy might lack the heavy elements necessary for rocky planets and complex chemistry. But there's a sweet spot, a ring around the galaxy where conditions are just right. Highways might preferentially pass through this zone, connecting worlds where life is most likely to emerge and thrive. As we contemplate these natural pathways through our galaxy, we begin to see that space isn't empty or featureless, but rich with structure and pattern. The galaxy has geography, weather, seasons, and currents. It has highways written in gravity and starlight, in dark matter and magnetic fields. Whether or not these highways are travelled by advanced civilizations, they exist as natural consequences of the physics that governs our universe. They're there, waiting to be discovered, mapped, and perhaps someday travelled. What if they're already here? What if the cosmic highways we've been imagining pass right through our solar system, and we simply haven't noticed the traffic? This isn't about UFOs or conspiracy theories, but about the very real possibility that our instruments and senses might be inadequate to detect technologies thousands or millions of years more advanced than our own. Tonight, let's gently explore the possibility that we might have visitors we cannot see, not because they're hiding, but because we don't yet know how to look. Consider how limited our perception really is. We see less than 1% of the electromagnetic spectrum. We can't detect magnetic fields without instruments. We're deaf to ultrasound and infrasound. We can't sense radioactivity, even though it can kill us. If we can miss so much of the natural world around us, how much might we be missing of the artificial? A civilization that has had millions of years to develop might use technologies that are as invisible to us as radio waves were to our ancestors just 2 centuries ago. The solar system is vast, mostly empty, and largely unexplored. We've sent probes to all the planets, but we've closely examined only tiny fractions of their surfaces. The asteroid belt contains millions of objects, and we've visited just a handful. The Kuiper belt beyond Neptune is even less explored, and the Oort cloud, that vast sphere of comets surrounding our solar system, might as well be terra incognita. There could be artifacts, probes, or even bases in our solar system that we simply haven't found yet, needles in a cosmic haystack. Arthur C. Clarke once said that any sufficiently advanced technology is indistinguishable from magic, but perhaps it's more accurate to say that sufficiently advanced technology might be indistinguishable from nature. If you can manipulate matter at the atomic level, if you can harness the fundamental forces of the universe, your artifacts might look like natural objects to less advanced observers. That asteroid might be a spacecraft. That comet might be a probe. That unusual moon might be an ancient monitoring station. Consider Oumuamua, the first confirmed interstellar object to pass through our solar system that we detected in 2017. It had an unusual elongated shape, unlike any asteroid or comet we've seen. It accelerated as it left our solar system in a way that couldn't be fully explained by gravity alone. Some serious scientists suggested it might be artificial, perhaps a light sail or a probe from another civilization. We'll never know for certain because Oumuamua is now too far away to study further. But it raises the question, how many other interstellar visitors have passed through our solar system unnoticed? The concept of von Neumann probes adds another layer to this possibility. These are self-replicating spacecraft that could explore the galaxy autonomously, making copies of themselves using raw materials from asteroids and moons. A single von Neumann probe could spawn millions of descendants over millions of years, spreading throughout the galaxy like a technological virus. These probes might be microscopic, no larger than dust grains, or they might disguise themselves as natural objects. Our solar system could be full of them, quietly observing, recording, waiting. But observation might be happening in ways we cannot even conceive. If consciousness can be uploaded or transmitted, alien visitors might not need physical bodies at all. They might exist as patterns of information in electromagnetic fields, as quantum states in the vacuum of space, as subtle manipulations of probability that we mistake for random chance. They might be here right now, all around us, as present and as invisible as the air we breathe. The zoo hypothesis, which we touched on earlier, suggests that Earth might be deliberately isolated, a preserve where life can evolve without interference. But maintaining such a preserve would require observation. There might be watchers ensuring that the quarantine is maintained, that no one interferes with our development. These watchers would need to be invisible to us, using technologies that leave no trace we can detect. They might observe from dimensions we cannot perceive, or from scales so large or small that we overlook them entirely. Our search for signs of visitors has been anthropocentric, looking for things we would recognize as artificial. We search for radio signals, laser pulses, megastructures, waste heat. But what if advanced civilizations have learned to be perfectly efficient, producing no waste heat? What if they communicate through quantum entanglement, leaving no electromagnetic signature? What if their structures are made of dark matter, invisible to our telescopes? We might be surrounded by evidence we cannot perceive. The temporal aspect adds another dimension to this puzzle. Visitors might not be here now, but they might have been here in the past, or they might arrive in the future. The solar system is 4.6 billion years old. If alien probes visited Earth 1 billion years ago, what traces would remain? Any artifacts left on Earth's surface would have been destroyed by erosion, buried by sedimentation, or recycled by plate tectonics. Even on the Moon, which has no atmosphere or geology to erase evidence, billions of years of micrometeorite impact would have erased or buried most traces. But there might be more durable signs. Isotopic anomalies in old rocks might indicate ancient mining or processing. Unusual distributions of elements in certain locations might be the residue of ancient technology. Some scientists have seriously proposed looking for such techno-signatures in Earth's geological record. We might be walking on evidence of ancient visitors without recognizing it. The possibility of visitors also raises questions about human history and mythology. Many ancient cultures have stories of beings from the sky, of teachers who brought knowledge, of times when the gods walked among humans. While these are almost certainly myths and metaphors, not historical records, they remind us that the idea of visitors from beyond Earth is as old as human consciousness. We've always looked up and wondered if someone might be looking back. Modern anomalies continue to puzzle us. Military pilots report objects that seem to defy physics, moving in ways that no known aircraft can match. These unidentified aerial phenomena, or UAPs, have been taken seriously enough that governments have established official programs to study them. While most probably have conventional explanations, atmospheric phenomena, sensor glitches, secret military projects, some remain genuinely mysterious. Could some of these be glimpses of technologies we don't understand? But let's step back from speculation and consider what physics tells us is possible. Quantum mechanics reveals a world where particles can be entangled across vast distances, where observation changes reality, where the vacuum seethes with virtual particles. General relativity shows us that space and time are flexible, that they can be warped and curved. These theories, well tested and confirmed, reveal a universe far stranger than our everyday experience suggests. In such a universe, what might be possible for a civilization with millions of years to explore these phenomena? Metamaterials, artificial materials with properties not found in nature, offer a glimpse of what might be possible. We've created materials that can bend light around objects, making them invisible to certain wavelengths. We've made materials with negative refractive indices that can focus light in ways that natural materials cannot. An advanced civilization might create metamaterials that are invisible to all forms of electromagnetic radiation, or that exist partially in other dimensions, or that can phase in and out of our reality. The concept of cloaking extends beyond just invisibility. Advanced civilizations might cloak their gravitational signatures, their thermal emissions, their very presence in space-time. They might have learned to slip between the quantum foam, existing in the spaces between spaces. They might manipulate probability itself, ensuring that we always happen to look in the wrong direction, that our instruments always happen to malfunction at crucial moments, that we always find natural explanations for artificial phenomena. But perhaps the most intriguing possibility is that visitors might not be entirely separate from us. Panspermia, the hypothesis that life spreads throughout the universe via meteorites or comets, suggests that life on Earth might have extraterrestrial origins. We might all be descendants of ancient visitors, our DNA carrying messages or programming from civilizations that seeded life throughout the galaxy. In this view, we're not waiting for visitors, we are the visitors, or at least their descendants. The microbiome that lives within us, the trillions of bacteria and other microorganisms that outnumber our own cells, might harbour its own mysteries. Some of these organisms have genes unlike anything else on Earth, sequences that seem to have appeared from nowhere. While this is probably the result of horizontal gene transfer and rapid evolution, it raises intriguing questions. Could some of our microscopic passengers be more foreign than we realise? As we lie here contemplating these possibilities, it's worth remembering that absence of evidence is not evidence of absence. We've barely begun to explore our own solar system, let alone the galaxy. Our instruments are primitive, our search methods limited, our assumptions potentially flawed. The visitors we cannot see might be a failure of our imagination rather than a fact of their absence. The universe has surprised us before. We discovered that atoms exist, that germs cause disease, that continents drift, that the universe is expanding. Each of these discoveries revealed a hidden layer of reality that was always there, waiting to be discovered. Perhaps visitors from other worlds are another such layer, present but not yet perceived, real but not yet recognized. As this first part of our journey draws toward a pause, not an end but a gentle resting point, consider that the question of visitors isn't really about whether they're here or not. It's about our readiness to expand our perception, to question our assumptions, to remain open to possibilities we haven't imagined. Whether or not our solar system hosts unseen visitors, contemplating the possibility stretches our minds and prepares us for a universe that is almost certainly stranger than we currently imagine. The night continues, and our journey through these cosmic mysteries has only just begun. In the chapters that follow, we'll explore even deeper questions about time, infrastructure, and our place in this vast, possibly travelled cosmos. But for now, let these thoughts settle like stardust in your mind, gentle and illuminating, as you drift deeper into the peaceful darkness that surrounds us all. Time is the ocean in which all cosmic events swim, and we humans are like mayflies skimming its surface, living and dying in what the universe considers a single moment. Our entire civilization, from the first agricultural settlements to our current technological age, spans perhaps 10,000 years. That sounds like a long time to us, but it's nothing, absolutely nothing, compared to the vast temporal scales on which the galaxy operates. Tonight, let's stretch our perception of time until it becomes elastic, until we can glimpse the slow, patient rhythms of a universe that measures its heartbeats in millions of years. Imagine a civilization that thinks in geological time, for whom a million years is like a decade to us. Such beings wouldn't be rushed by the vast distances between stars. They wouldn't see interstellar travel as an insurmountable challenge, requiring faster-than-light travel or exotic physics. They would simply be patient, launching ships that take thousands or millions of years to reach their destinations, secure in the knowledge that their civilization will still exist when those ships arrive. To them, the galaxy wouldn't seem impossibly vast, but merely large, like an ocean that takes time to cross but is ultimately navigable. Consider how our perception of time is shaped by our biology. Our hearts beat about once per second. We live for roughly 1 billion heartbeats. Our generations span about 25 years. These biological rhythms create our sense of urgency, our feeling that time is limited and precious. But what if intelligence could exist with different rhythms? What if there are beings whose heartbeats span centuries, whose thoughts unfold over millennia, whose civilizations rise and fall in timescales that dwarf the entire history of our solar system? Silicon-based computers can already operate millions of times faster than biological neurons. A sufficiently advanced artificial intelligence might experience subjective years in what we would consider seconds. Conversely, it might slow its processing down, experiencing seconds as years, essentially hibernating through vast stretches of time. For such beings, interstellar travel might be trivial. They could slow their subjective time to a crawl, experiencing a million-year journey as a brief nap, or speed it up, living entire civilizations worth of subjective time during a single orbit of their planet. The galaxy itself operates on multiple timescales simultaneously. Stars like our Sun live for billions of years, steadily fusing hydrogen into helium, providing stable energy for any planets that might orbit them. Massive stars burn through their fuel in just millions of years, living fast and dying young in spectacular supernovae. Red dwarf stars, the most common type in our galaxy, can shine steadily for trillions of years, longer than the current age of the universe. Each type of star creates its own temporal context, its own rhythm of energy and evolution. Planetary systems also have their own temporal dynamics. Orbits create cycles, days, years, seasons. Geology operates on longer scales, mountain ranges rising and eroding over millions of years, continents drifting and colliding over hundreds of millions of years. Climate cycles span thousands to millions of years, ice ages coming and going like slow breaths. Life evolves on even longer scales, with major evolutionary transitions taking tens or hundreds of millions of years. A galactic civilization would need to think on all these scales simultaneously, planning for changes that unfold over eons. The concept of deep time changes everything about how we might think about galactic highways. Routes that seem permanent to us might be temporary on geological scales. Stars move relative to each other, slowly rearranging the stellar neighborhood. In 1,000,000 years, the constellations we know will be unrecognizable. Proxima Centauri won't always be our nearest stellar neighbor. The stars we see as distant today might be our close companions in the future, while our current neighbors drift away into the darkness. Our solar system's journey through the galaxy adds another layer of temporal complexity. We complete an orbit around the galactic center every 225 million years, a period sometimes called a galactic year. During each orbit, we pass through different regions of the galaxy, encountering different stellar densities, different levels of radiation, different gravitational influences. We oscillate up and down through the galactic disk, like a horse on a carousel, completing a full cycle every 60 million years or so. These motions might carry us through cosmic highways periodically, like a planet with seasons of isolation and seasons of connection. Some scientists have suggested that these galactic motions might influence life on Earth. Mass extinctions seem to occur with a certain periodicity that may correlate with our passage through the galactic disk, or our exposure to increased cosmic radiation. If this is true, then our position in the galaxy isn't just a matter of cosmic geography but of cosmic chronology. We might be living in a particular temporal window, a specific moment in our galactic journey that has allowed complex life to flourish. The Fermi paradox takes on new dimensions when we consider these vast timescales. Civilizations might rise and fall like waves on a beach, each one lasting only a few thousand or million years before disappearing. The galaxy might be full of civilizations, but they might be scattered in time rather than space. We might be surrounded by the ruins of dead civilizations and the seeds of future ones, living in a brief moment between waves of intelligence. The silence we perceive might be temporal rather than spatial. We're not alone in the galaxy. We're just alone right now. Or perhaps civilizations that survive long enough transcend our normal understanding of time. They might learn to manipulate time itself, speeding it up or slowing it down, creating bubbles of altered time where millions of years pass in seconds, or seconds stretch into millions of years. They might exist partially outside of time, experiencing past, present, and future simultaneously. For such beings, the concept of galactic highways might be meaningless, as they could be everywhere and everywhen at once. The concept of the technological singularity suggests that civilizations might experience exponential growth that fundamentally changes their relationship with time. Once artificial intelligence surpasses human intelligence and can improve itself, the rate of change might accelerate beyond our ability to comprehend. A civilization might go from roughly our level of technology to something godlike in a matter of decades or centuries. From a galactic perspective, such civilizations might appear and transcend almost instantaneously, like fireworks flashing briefly against the cosmic darkness. But perhaps some civilizations choose the opposite path, deliberately slowing down their development to ensure long-term survival. They might recognize that rapid growth leads to rapid resource depletion, that fast-burning civilizations exhaust themselves like massive stars. Instead, they might adopt a philosophy of patience, of sustainability, of thinking in geological or astronomical timescales. They might spread slowly through the galaxy, taking millions of years to establish each new colony, ensuring that their expansion is stable and permanent rather than explosive and brief. The concept of generation ships illustrates one way civilizations might adapt to these vast timescales. These are spacecraft designed to support populations for thousands or millions of years, with generations living and dying aboard the ship during its journey between stars. The original launchers of the ship would never see its destination, nor would their children or their children's children. But the civilization as a whole would spread through the galaxy, accepting the vast timescales as a natural part of existence. Hibernation or suspended animation offers another approach to dealing with cosmic timescales. If biological beings could be frozen or otherwise preserved for millions of years, they could sleep through the long journeys between stars, awakening only when they reach their destination. The galaxy might be full of sleeping travelers, dormant seeds of civilization drifting between stars, waiting for the right conditions to awaken and bloom. Our solar system might have passed through clouds of such dormant probes or seeds without ever knowing it. Digital consciousness opens even more radical possibilities for dealing with time. If minds can be uploaded into computers, they could be paused, backed up, restored, and copied. A digital civilization could send copies of itself to distant stars at the speed of light, transmitted as radio or laser signals. Upon arrival, these signals could be used to reconstruct the civilization using local resources. Time would become just another variable to be managed, another dimension in which to exist and explore. The life cycle of the universe itself provides the ultimate temporal context. Our universe is about 13.8 billion years old, and it might continue expanding for trillions of years to come. The era of stars, when energy is readily available from stellar fusion, will last for perhaps 100 trillion years. After that, the universe will enter the degenerate era, when only white dwarfs, neutron stars, and black holes remain. Eventually, even black holes will evaporate through Hawking radiation, leaving a cold, empty universe in the far distant future. Civilizations thinking on these ultimate timescales might have plans and purposes we cannot fathom. They might be working on projects that take billions of years to complete, engineering entire galaxies, or even attempting to escape the heat death of the universe. They might see our current era, the stelliferous era when stars still shine, as just the beginning, the morning of a cosmic day that will last for eons beyond imagination. Their highways might be designed not just for travelling through space, but for travelling through time, carrying them into the deep future. The concept of the Kardashev scale, which classifies civilizations by their energy use, implicitly involves timescales. A Type 1 civilization harnesses the energy of its planet. A Type 2 civilization harnesses the energy of its star. A Type 3 civilization harnesses the energy of its galaxy. Moving from one level to the next might take millions or billions of years. The galaxy might be stratified by time as well as space, with young civilizations like ours at the bottom and ancient ones at the top, separated by gulfs of time we can barely imagine. As we contemplate these vast temporal scales, our own brief existence takes on a poignant quality. We are mayflies, yes, but we are mayflies who've learned to contemplate eternity. We live for just a cosmic instant, but in that instant we've developed the ability to think about billions of years, to plan for the future, to dream of immortality. We might be temporally insignificant, but we're not temporally ignorant. We know our place in time, even if we cannot transcend it. The search for extraterrestrial intelligence might need to account for these temporal disparities. We've been searching for less than a century, listening for signals from civilizations that might have died millions of years ago, or might not be born for millions of years to come. We might need to search for thousands or millions of years before we find anyone, not because intelligence is rare, but because it's scattered in time. Patience might be the most important quality for a successful SETI program. Infrastructure is the skeleton of civilization, the framework that allows complex societies to function. On Earth, we have roads and bridges, power grids and communication networks, pipelines and ports. These systems, mostly invisible in daily life, enable the flow of goods, energy and information that keeps our world running. Now, let's expand our thinking to cosmic scales and consider what infrastructure might look like for civilizations that span star systems or galaxies. What are the cosmic equivalents of highways and power lines? What invisible frameworks might support interstellar civilizations? The concept of Dyson spheres represents one of the most famous ideas about cosmic infrastructure. Proposed by physicist Freeman Dyson, these are hypothetical megastructures that would surround a star, capturing most or all of its energy output. A Dyson sphere wouldn't necessarily be a solid shell. That would be unstable and probably impossible to build. Instead, it might be a swarm of satellites, each one collecting solar energy and beaming it to where it's needed. From a distance, a star surrounded by a Dyson swarm might appear dimmer than it should be in visible light, but brighter in infrared, as the collected energy is re-radiated as waste heat. We've actually been searching for Dyson spheres, looking for stars with unusual infrared signatures that might indicate artificial energy collection. Some stars show promising anomalies, though none have been confirmed as artificial. Tabby's star, formerly known as KIC 8462852, exhibits irregular dimming patterns that some scientists initially suggested might be caused by an alien megastructure. While natural explanations now seem more likely, the search continues. The galaxy might be dotted with Dyson spheres that we haven't recognized yet, cosmic power plants that fuel interstellar civilizations. But energy collection is just one type of infrastructure. Communication networks might be even more important for galactic civilizations. We've already discussed the possibility of using pulsars as navigational beacons, but they might serve broader infrastructure purposes. A network of artificial pulsars or modified natural ones could serve as a galactic internet, transmitting information across vast distances with precise timing. The seemingly random variations in some pulsar signals might actually be encoded messages, a cosmic conversation we're not equipped to decode. Gravitational lensing might be harnessed as communication infrastructure. The gravity of stars and galaxies bends light, creating natural telescopes and amplifiers. An advanced civilization might position relay stations at the focal points of gravitational lenses, using the galaxy's own mass to boost their signals across cosmic distances. What we see as empty points in space might actually be nodes in a vast communication network, invisible to us because they only activate when transmitting or receiving. The concept of stellar engines takes infrastructure to another level entirely. These are hypothetical megastructures that could move entire stars, turning them into cosmic tugboats. A Shkadov thruster, for example, would be a massive mirror that reflects a star's light in one direction, creating thrust that slowly pushes the star in the opposite direction. Over millions of years, this could be used to move a star and its entire planetary system to a new location. Civilizations might use stellar engines to cluster useful stars together, to escape dangerous cosmic events, or to travel through the galaxy as a united system. If stellar engines exist, they might leave detectable signatures. Stars moving in unusual ways, stars with asymmetric emissions, or stars that seem to be clustering in unnatural patterns might be evidence of cosmic engineering. The galaxy's structure itself might be partially artificial, shaped by millions of years of stellar manipulation by ancient civilizations. What we interpret as natural stellar dynamics might include the deliberate movements of engineered star systems. Wormholes, if they exist and can be stabilized, would represent the ultimate transportation infrastructure. These shortcuts through space-time would allow instant travel between distant points in the universe. Creating or maintaining a wormhole might require exotic matter with negative energy density, something we don't know how to produce or even if it's possible to produce, but for a sufficiently advanced civilization, a network of wormholes might connect the galaxy like a subway system, with stations at key locations and routes between major civilizations. The search for wormholes is challenging, because we don't know exactly what they would look like. They might be microscopic, invisible to our telescopes, or they might masquerade as black holes or other massive objects. The recent discovery of gravitational waves has given us a new tool for probing the structure of space-time. Unusual gravitational wave signatures might someday reveal the presence of wormholes or other exotic structures that serve as cosmic infrastructure. Dark matter might play a crucial role in cosmic infrastructure. Making up about 85% of the matter in the universe, dark matter is invisible to our telescopes but shapes the structure of galaxies through its gravity. What if dark matter isn't natural but is instead the waste product or even the construction material of advanced civilizations? What if the dark matter halos that surround galaxies are actually vast machines or computers, processing information on scales we can't imagine? This might sound like wild speculation, but consider that we have no idea what dark matter actually is. We know it exists because we can see its gravitational effects, but we've never directly detected a dark matter particle. It could be something mundane, like unknown subatomic particles, or it could be something extraordinary, like the infrastructure of civilizations that have transcended normal matter. The fact that dark matter seems to ignore normal matter except through gravity might make it ideal for certain types of cosmic engineering. Cosmic voids, the vast empty regions between galaxy clusters, might not be as empty as they appear. These voids could be cleared spaces, regions where advanced civilizations have harvested all the matter for their projects, or they might be preserves, areas deliberately kept empty for reasons we don't understand. The structure of the cosmic web itself, with its filaments and voids, might be partially engineered, shaped by billions of years of cosmic infrastructure development. The interstellar medium, the gas and dust between stars, might be seeded with nanotechnology. Microscopic machines, capable of self-replication and programmed for specific tasks, could spread throughout the galaxy like a technological ecology. These machines might be too small for us to detect individually, but in aggregate, they might alter the properties of interstellar space. Unusual chemical abundances, unexpected dust compositions, or anomalous physical properties of certain regions might be signs of nanotechnological infrastructure. Quantum entanglement might provide the basis for instantaneous communication across the galaxy. While our current understanding suggests that entanglement can't be used to transmit information faster than light, a more advanced understanding of quantum mechanics might reveal loopholes. A network of entangled particles distributed throughout the galaxy could serve as a communication system that operates outside the normal constraints of space-time. The seemingly random quantum fluctuations we observe might include encoded messages we don't know how to read. Black holes might be the ultimate infrastructure elements. These cosmic monsters, where space-time curves to infinity, might be harnessed for various purposes. They could be used as power sources, extracting energy from infalling matter or from their rotation. They might serve as computational devices, using the extreme physics near their event horizons to perform calculations impossible elsewhere. They could be garbage disposals, places to safely dispose of dangerous waste. Or they might be gateways, portals to other universes or other regions of our own universe. The merger of black holes, which we now detect through gravitational waves, might not always be natural events. Advanced civilizations might orchestrate these mergers, using the released energy for massive engineering projects, or using the gravitational waves themselves as a form of communication. The patterns of black hole mergers we observe might include artificial signatures we haven't learned to recognize. Matryoshka brains represent another type of possible infrastructure. Nested shells of computational material surrounding a star, using all of its energy for information processing. Such a structure would be the ultimate computer, capable of simulating entire universes or housing billions of uploaded consciousnesses. A star surrounded by a Matryoshka brain might be invisible to our telescopes, all of its light converted to computation and then re-radiated as low-temperature waste heat. The concept of the cosmic commons suggests that advanced civilizations might establish shared infrastructure that any spacefaring species can use. Just as we have international waters and Antarctica on Earth, there might be cosmic territories and resources that belong to all civilizations. Certain pulsars might be designated as public beacons. Certain star systems might be maintained as refueling stations. There might be agreed-upon communication channels and protocols that we haven't discovered yet. Time capsules or information caches might be scattered throughout the galaxy, preserving the knowledge and history of civilizations for future discoverers. These might be hidden in stable locations, Lagrange points inside asteroids, on moons of gas giants. They might be designed to reveal themselves only to civilizations that have reached a certain level of technological development. We might be surrounded by libraries of cosmic knowledge, waiting for us to develop the keys to unlock them. The zoo hypothesis, viewed through the lens of infrastructure, suggests that there might be observation posts throughout our solar system, hidden stations where Earth is monitored. These wouldn't necessarily be physical structures. They might be swarms of microscopic sensors, clouds of smart dust that observe and report without being detected. Every asteroid that passes near Earth, every comet that enters the inner solar system, might carry hidden observers, part of an infrastructure of surveillance we cannot perceive. Megascale engineering might reshape entire solar systems or even galaxies. Civilizations might disassemble planets to build massive structures. They might move stars to create optimal configurations. They might even merge galaxies or prevent them from merging depending on their needs. The universe we observe might be heavily engineered, but the engineering might be so ancient and extensive that we mistake it for nature. Our planet is a traveller, though we rarely feel its motion. Earth spins on its axis, orbits the Sun, moves with the Sun around the galactic centre, and participates in the general expansion of the universe. We are never in the same place twice. constantly moving through space on multiple trajectories simultaneously. Understanding Earth's place in this cosmic dance, our position in the vast web of matter and energy that makes up the universe, might reveal whether we sit near cosmic highways or in cosmic backwaters, whether we're in the flow of galactic traffic or isolated in a quiet eddy. Let's begin with our immediate neighbourhood. Earth orbits the Sun at about 30 kilometers per second, tracing an ellipse that brings us slightly closer and farther from our star over the course of a year. But the Sun itself is moving, carrying us along at about 220 kilometers per second as it orbits the galactic centre. We're also bobbing up and down through the galactic disk, currently moving upward about 50 light-years above the midplane and rising. These motions aren't separate but combined, creating a complex helical path through space, like a spring being stretched and twisted simultaneously. Our solar system resides in what we call the local interstellar cloud, a region of relatively dense gas about 30 light-years across. We entered this cloud somewhere between 44,000 and 150,000 years ago, and will remain within it for another 10,000 to 20,000 years. This cloud is itself moving, flowing through space at about 26 kilometers per second. We're not just in the cloud, we're moving through it, like a boat crossing a river that's itself flowing toward the sea. The local bubble, which we discussed earlier, provides the broader context for our journey. This cavity in the interstellar medium, carved out by ancient supernovae, is about 300 light-years across. We're not at its centre, but offset, closer to one edge. The local bubble is connected to other bubbles through chimney-like structures, creating a network of low-density regions through the galaxy. We might be near one of these connections, a cosmic intersection where different regions of space meet. Our position in the Milky Way's spiral structure places us in the Orion arm, also called the local arm, a minor spiral feature between the major Perseus and Sagittarius Carina arms. We're about 26,000 light-years from the galactic centre, in what might be considered the suburbs of our galaxy. This position has implications for our exposure to cosmic events. We're far enough from the galactic centre to avoid its intense radiation and gravitational chaos, but close enough to be in a region enriched with heavy elements from billions of years of stellar evolution. The galactic habitable zone, that ring around the galaxy where conditions are suitable for life as we know it, isn't static. It moves outward over time as the galaxy evolves and stellar populations age. Earth has been in this zone for most of its history, but this hasn't always been guaranteed. Our orbit around the galaxy carries us through different environments, sometimes closer to spiral arms where star formation is active and supernovae more common, sometimes in quieter inter-arm regions where we currently reside. Our Sun's peculiar motion relative to nearby stars, called the solar apex motion, carries us toward the constellation Hercules at about 20 kilometers per second. This means we're constantly encountering new stellar neighbours while leaving others behind. Stars that are distant today might become close neighbours in 1,000,000 years. Gliese 710, currently about 64 light-years away, will pass within a light-year of our Sun in about 1.3 million years, potentially disturbing the Oort cloud and sending comets into the inner solar system. The concept of stellar streams adds another dimension to our cosmic position. These are groups of stars that share similar orbits, often remnants of disrupted star clusters or dwarf galaxies. Our Sun might have originated in such a cluster, born alongside siblings that have since dispersed throughout the galaxy. Finding and studying these stellar siblings could tell us about our origins and our future trajectory through space. Our galaxy itself is moving, part of the local group of galaxies that includes Andromeda, the Triangulum Galaxy, and dozens of smaller galaxies. The local group is falling toward the Virgo cluster, pulled by its immense gravity. But the Virgo cluster is itself moving, part of the larger Virgo supercluster, which is being pulled toward the Great Attractor, a gravitational anomaly hundreds of millions of light years away. We're part of a cosmic flow, rivers of galaxies streaming through space on scales that dwarf human comprehension. The cosmic web, that larger scale structure of the universe, positions us in a relatively ordinary location. We're not in a dense cluster where galaxies crowd together, nor are we in a vast void where galaxies are rare. We're in a filament, one of the threads that connect the nodes of the cosmic web. If civilizations follow the structure of matter in the universe, these filaments might be the highways, the routes along which intelligence spreads from galaxy to galaxy. Our temporal position might be just as important as our spatial position. We exist about 13.8 billion years after the Big Bang, in what cosmologists call the stelliferous era, when stars actively form and shine. This era will continue for trillions of years, but we're still relatively early. The universe has produced only about 5% of the stars it will ever create. We're like early morning commuters, travelling through a cosmos that will become much busier in the cosmic afternoon. The metallicity of our region of space, the abundance of elements heavier than hydrogen and helium, affects the possibility of life and technology. These heavy elements, forged in stars and supernovae, are essential for rocky planets and complex chemistry. Our Sun has a relatively high metallicity for its age, suggesting we're in a region enriched by previous generations of stars. This might make our neighbourhood particularly suitable for life, and therefore more likely to be on or near cosmic highways. Earth's magnetic field creates a protective bubble around our planet, the magnetosphere, which deflects harmful cosmic radiation and solar wind. This magnetic shield has been crucial for the development and persistence of life on Earth. But it also might make Earth detectable from great distances. Our magnetosphere creates radio emissions, particularly during geomagnetic storms. We might be broadcasting our presence in ways we don't fully appreciate, a beacon in the cosmic darkness. The Moon's influence on Earth adds another unique aspect to our cosmic position. Our unusually large Moon stabilizes Earth's rotation, preventing chaotic changes in our axial tilt that would cause extreme climate variations. The Moon also creates tides, which might have been crucial for the development of life. The Earth-Moon system is relatively rare, and this might make us a point of interest for cosmic travellers, a unique destination worth visiting or avoiding, depending on their intentions. Our planet's history of mass extinctions might be connected to our journey through the galaxy. Some scientists have proposed that extinction events correlate with our passage through the galactic disk, or our proximity to spiral arms. If this is true, we might be able to predict future dangerous periods based on our trajectory through space. We might also be able to identify past visitors or influences by looking for anomalies in the fossil record that coincide with our passage through different regions of the galaxy. The Oort cloud, that vast sphere of comets surrounding our solar system, extends perhaps halfway to the nearest star. This means the Oort clouds of neighbouring stars might overlap, creating bridges of material between star systems. Comets might occasionally transfer between stars, carrying with them organic materials or even microbial life. We might be more connected to our stellar neighbours than we realise, linked by these bridges of ice and rock, the heliosphere, the bubble of solar wind that surrounds our solar system, pulses with the solar cycle, and changes shape as we move through different regions of interstellar space. Right now, we're in a region where the interstellar medium is relatively thin, allowing our heliosphere to expand. But as we move into denser regions, it will compress, potentially allowing more cosmic radiation to reach the inner solar system. These changes might affect the habitability of Earth and the visibility of our solar system to outside observers. Our solar system's architecture, with the rocky planets close to the Sun and gas giants farther out, might be relatively unusual. The discovery of hot Jupiters, gas giants orbiting very close to their stars, has shown us that planetary systems can have very different configurations. Our system's structure, with Jupiter acting as a cosmic vacuum cleaner that protects the inner planets from many asteroid and comet impacts, might make us special. This architecture might be a signpost for cosmic travellers, indicating a system where life has had a chance to develop undisturbed. The Kuiper Belt and scattered disk, regions of icy bodies beyond Neptune, might hold clues to our solar system's past and future. These objects are pristine, preserving materials from the solar system's formation. But they might also hold artifacts or evidence of past visitors. The unusual orbits of some Kuiper Belt objects have led to speculation about a ninth planet or other massive object in the outer solar system. Could this be natural, or might it be something else? As we consider Earth's place in the cosmic web, we see that we're neither central nor isolated. We're part of a vast, interconnected system of matter and energy, flowing through space on multiple scales simultaneously. We're in motion, always have been, always will be. Our position is constantly changing, which means our relationship to any cosmic highways must also be dynamic. We might be approaching a busy intersection or leaving one behind. We might be entering a cosmic city or departing for the wilderness. And so we arrive at the end of our journey, though in truth there are no endings in the cosmos, only transformations, only new beginnings disguised as conclusions. We've travelled together through vast scales of space and time, contemplated civilizations beyond our imagination, and wondered about highways we cannot see. Now, as the night deepens around us, let's bring all these threads together into a tapestry of wonder, a meditation on what it means to possibly live near a cosmic highway, whether that highway is real or metaphorical, physical or philosophical. The question we began with, could we be living in a quiet galactic highway, has revealed itself to be many questions woven together. Are we alone in the universe? If not, how do other civilizations travel and communicate? Why does the cosmos seem so quiet? What is our place in the grand architecture of space and time? These questions don't have definitive answers, at least not yet, and perhaps that's as it should be. The mystery is beautiful in itself, a gift that keeps us wondering, searching, dreaming of possibilities beyond our current understanding. Consider what we've discovered on this journey. We've seen that the galaxy has structure, patterns and pathways that might serve as natural routes for travel. Spiral arms and stellar streams, bubbles and voids, gravitational currents and magnetic fields, all create a kind of cosmic geography that intelligent beings might navigate. We've contemplated how advanced civilizations might use technologies we can barely imagine, harnessing the fundamental forces of nature, building infrastructure on scales that dwarf planets and even stars. We've wrestled with the Fermi paradox, the strange silence of a cosmos that should be noisy with intelligence. We've also confronted our own limitations, the narrow slice of reality we can perceive, the brief moment of cosmic time we inhabit. We are mayflies contemplating eternity, and yet, remarkably, we can contemplate it. We can imagine billions of years, visualize billions of light years, theorize about dimensions beyond our three-dimensional experience. This capacity for cosmic imagination might be our greatest achievement as a species, more important than any technology we've created or will create. The possibility that Earth sits near a galactic highway raises profound questions about our future. If we are near routes travelled by advanced civilizations, what does that mean for humanity? Are we being observed, studied, protected? Are we being ignored, considered too primitive to contact? Or are we simply unnoticed, like ants beside a human highway, irrelevant to the cosmic traffic flowing past us? Each possibility carries its own implications, its own hopes and fears. But perhaps we're thinking about this backward. Perhaps the question isn't whether we're near a cosmic highway, but whether we're ready to perceive one if we are. Our science is young, our instruments primitive by cosmic standards. We've been listening to space for less than a human lifetime. We've sent probes to the planets, but explored only tiny fractions of their surfaces. We've detected gravitational waves and neutrinos, dark matter and dark energy, but we don't fully understand any of them. We're like children who have just learned to read, trying to understand a library written in languages we don't yet know exist. The search for cosmic highways might ultimately be a search for ourselves, for our place in the universe, for meaning in the vast darkness. Every time we look up at the stars and wonder if someone is travelling between them, we're really asking who we are, why we're here, where we're going. These are the eternal questions that have driven human curiosity since we first developed the capacity for abstract thought. The cosmic highway is a modern metaphor for an ancient quest, the search for connection, for purpose, for our role in the grand story of existence. And what a story it is. From the Big Bang to the present moment, from quantum fluctuations to galactic superclusters, from simple chemistry to conscious beings capable of contemplating their own existence, the universe has been writing an epic that dwarfs any human narrative. We're characters in this story, brief appearances in a tale that began billions of years before us and will continue billions of years after us. But we're special characters because we can read the story, at least parts of it. We can appreciate the plot, wonder about the ending, imagine alternative narratives. If galactic highways exist, they're part of this story. They represent the possibility that intelligence is not rare but common, that consciousness is not an accident but a feature of the universe, that we're not alone but part of a vast community we haven't yet learned to perceive. They suggest that the universe might be more alive than we imagine, filled with thought and purpose and meaning. They hint at futures we can barely conceive, when humanity might join this galactic community, contributing our own unique perspective to the cosmic conversation. But even if galactic highways don't exist in any physical sense, the concept serves a purpose. It stretches our imagination, challenges our assumptions, prepares us for a universe that is almost certainly stranger than we currently believe. It reminds us that absence of evidence is not evidence of absence, that we've barely begun to explore the cosmos, that wonders beyond our current comprehension might be waiting just beyond our perception. The silence of the cosmos might be the most profound sound we've ever heard. It might be telling us we're alone, the only conscious observers in a vast, indifferent universe, or it might be telling us we're not listening correctly, that we need to develop new senses, new instruments, new ways of thinking. It might be a test, a filter that only patient, persistent civilizations can pass. Or it might be an illusion, a misperception that will suddenly resolve into obvious signals once we know how to look. As you lie there in the darkness, perhaps feeling sleep beginning to claim you, consider that you are already on a cosmic highway. Your body is made of atoms forged in dying stars, elements that have travelled across the galaxy to be here, now, assembled into the pattern that is you. You are cosmic material organised into consciousness, the universe looking at itself, wondering about itself. Every breath you take exchanges atoms with the atmosphere, which exchanges atoms with space. You're not separate from the cosmos, but an expression of it, a temporary arrangement of eternal materials. The calcium in your bones might have been part of a planet orbiting another star, a world that was destroyed when its sun died, its materials scattered into space to eventually become part of Earth, and then part of you. The water in your cells might have been ice on comets that sailed between stars for millions of years before falling to Earth. The iron in your blood might have witnessed the birth of galaxies. You are a collection of cosmic travellers temporarily gathered into the pattern of your existence. This perspective transforms the question of galactic highways from one of external speculation to one of internal recognition. We're not waiting to join the cosmic community. We are already part of it. We're not hoping to someday travel the stars. We're already stellar material in motion. We're not separate from the cosmic highway. We're expressions of it, manifestations of the same forces and materials that create stars and planets, and possibly other forms of consciousness throughout the universe. The night sky, which might seem empty and silent, is actually full of connections. Every photon of starlight that reaches your eye has travelled for years, decades, centuries, or millennia to bring you information about distant suns. You're in direct physical contact with the cosmos through these particles of light. The gravity of distant galaxies pulls on you, infinitesimally but measurably. Neutrinos from the sun, from supernovae, from the Big Bang itself, pass through your body by the trillions every second. You're immersed in the cosmos, swimming in it, made of it. Perhaps the real mystery isn't whether we're near a galactic highway, but why we feel so separate from the cosmos when we're so intimately connected to it. Maybe this feeling of separation is necessary for consciousness, creating the distinction between self and universe that allows for observation and wonder. Or maybe it's an illusion we'll eventually overcome, recognizing our deep integration with everything around us. The future stretches before us, full of possibilities. In the coming decades, we'll build better telescopes, more sensitive instruments, new ways of observing the universe. We might detect signals from other civilizations, or we might discover new phenomena that reshape our understanding of physics. We might find evidence of cosmic highways, or we might realize the universe is stranger than any highway we can imagine. We might make contact, or we might discover we're alone, or we might find something in between, something we don't yet have words for. But whatever we discover, the search itself changes us. Every time we look up at the stars and wonder, we become more than we were. Every question we ask about the cosmos expands our consciousness. Every possibility we imagine prepares us for futures we cannot predict. The contemplation of galactic highways, whether they exist or not, makes us citizens of the universe rather than just residents of Earth. As sleep approaches, carrying you into your own temporary journey away from waking consciousness, remember that you are part of something vast and mysterious and beautiful. You are a way for the universe to know itself, a brief flowering of awareness in an ocean of matter and energy. Whether or not galactic highways exist in any physical sense, you're already travelling on the greatest highway of all, the journey of existence itself, the path from Big Bang to unknown future, the road that connects every particle and wave, every star and planet, every thought and dream. The mystery of our cosmic address isn't a problem to be solved, but a gift to be treasured. It keeps us curious, keeps us searching, keeps us dreaming of possibilities beyond our current understanding. It reminds us that the universe is far larger and stranger than we can imagine, that wonders beyond comprehension might be waiting just beyond the next star, the next discovery, the next moment of cosmic time. And so, as this documentary draws to its close, we leave you not with answers, but with wonder. The question of whether we're living in a quiet galactic highway remains open, a beautiful uncertainty that invites continued exploration. Perhaps tomorrow, or next year, or next century we'll know more. Perhaps we'll discover that we've been surrounded by cosmic traffic all along, or perhaps we'll confirm our cosmic solitude. Or perhaps, most likely, we'll discover something we never expected, something that makes our current questions seem quaint and primitive. But tonight, in this moment, the mystery is perfect just as it is. It connects us to the cosmos and to each other, fellow travellers wondering about our place in the vast darkness. It makes us part of a story that began with the Big Bang and continues into an uncertain but surely wondrous future. It transforms us from isolated individuals into participants in the greatest adventure possible, the adventure of consciousness exploring itself and its universe. Sleep now if sleep is coming, and know that you rest in a cosmos full of possibilities. Whether or not we live near a galactic highway, we live in a universe where such things can be imagined, and that itself is a kind of miracle. The stars wheel overhead, following their ancient paths, carrying their secrets. The galaxy spins, patient and vast, its spiral arms sweeping through space like the hands of a cosmic clock. And somewhere in that vastness, on a small blue planet orbiting an ordinary yellow star, consciousness has awakened and begun to wonder about its place in the grand design. That wondering is perhaps the most beautiful thing in the universe, not the highways themselves if they exist, but our capacity to imagine them, to search for them, to dream of the day when we might travel them ourselves. For in that wondering, in that searching, in that dreaming, we become more than mere matter. We become the universe contemplating itself, and that is the greatest journey of all. The cosmos continues its patient spinning, stars are born and die, galaxies dance their slow spirals through the void, and somewhere, perhaps, travellers move along routes we cannot yet perceive. But here, now, in this moment, you are exactly where you need to be. Part of the mystery, part of the wonder, part of the vast and beautiful question that is existence itself. And whether or not we live near a galactic highway, we live in a universe magnificent enough to make such things possible, and that is wonder enough for any night, any lifetime, any journey through the stars.